Okay guys, so for question 4, 4a, from the data in the table above, what does the half-life of the reaction tell you about the order of the reaction? Well, as you all pretty much correctly surmised, the half-life is not constant, but that does not mean it is a second order reaction. That means it is not a first order reaction. It could be third order, fourth order, fifth order, etc. And the half-life would not be constant still. So please keep that in mind, okay? Now, for B, the natural log concentration versus time and reciprocal of concentration versus time was graphed. What is the order of the reaction? Well, it is second order because the reciprocal, the 1 over B, concentration B graph against time gives you a straight line. Okay. Now for C, you use the formula given in your formula sheet, which is 1 over A at T minus 1 over initial A equals KT. Okay, so you're given the initial concentration at time equals 0 for in the data table. So you know you're going to have 1 over 0.2, and minus that you can choose any time point, I believe. So let's say we choose 5 seconds. So 1 over 0.034 equals K times 5. So I'm using my data table. I'm using time equals 5. So I'm using the concentration of NO2 at time equals 5. I'm using my initial concentration. And for KT part, I'm doing 5K. And when you solve all of that through, you'll get your correct answer. Okay. Now finally, for D, this is quite a tough one, especially in terms of NO2. I think that it is better to talk more about the free chlorine atoms. A free chlorine atom therefore means a chlorine with 7 valence electrons. To say it, you can say it has an odd number of electrons, or you could say that it is very unstable. It will take an electron from anything in order to become more stable. That would be sufficient, okay? So you could talk about chlorine atoms have a need to fill its outer shell, or an extra or an unpaired electron. I mean, I think you'd be able to understand the idea of an unpaired electron. This, by the way, is kind of referred to as a radical, generally speaking. But something that has an unpaired electron is going to try and pair that electron up with anything, and it pairs it up with NO2, and that would be sufficient to answer that question.